I have already bought the materials for the project, which I used to build my actual project from the simulation.
Good day! I am going to present to you my Arduino Uno project. First, I am going to discuss the truth table to which my Arduino Uno project would operate. The inputs of my project are 3 push buttons. The outputs are 3 LEDs, a buzzer, and a servo. Here is the truth table of my project. It will operate so that each output LED will blink when its corresponding switch is pressed. When the first button is pressed, the red LED blinks. When the second button is pressed, the green LED blinks. And when the third button is pressed, the blue LED blinks. The buzzer will beep if just one or all 3 of the LED lights up. The servo points to the sequence number, with each sequence number corresponding to an input combination. The table lists the sequence chronologically from sequence 0 to sequence 7. The first line #include_servo.h includes the servo library that allows an Arduino board to control servo motors. The next 2 lines declare variables such as new underscore and old underscore. When in a loop, the new underscore variable will store the input sequence of the current loop, and the old underscore variable will store the input sequence of the previous loop. Variables servo pin and buzzer were declared a constant integer and was given values 8 and 9 respectively. Variable servo1 was also declared as a servo variable. The setup function is a function that occurs only once. Generally, it prepares the Arduino board before it operates. I used the for loop to make pin 2 to 4 input pins and another for loop to make pin 5 to 7 output pins. The variable servo1 is attached to the servo pin, which is 8. The pin for the buzzer was also assigned as output. The loop function is defined as shown. This loop is a function that repeats infinitely. I only put a placeholder in the body of the function since its whole content is quite long. Hence, I have broken them into parts. This is the first part of the loop function. The new underscore variable were first initialized as 0. The if statements read each pin, and corresponding powers of 2 was added to the new underscore variable if that pin has a high value. It is as if the 3 inputs was a binary number and then converted to decimal, with the least significant bit in pin 2 and the most significant bit in pin 4. The new underscore variable can be referred to as the new input sequence. The next part of the loop function are if-else statements to define what happens to the outputs in each new input sequence. If the first condition is not satisfied, it moves to the next conditions until a condition is satisfied. In each condition, the digital write function was used to put each pin in a low or high state. The LED connected to a pin will light up if the pin is in a high state and will not light up if the pin is in a low state. The red, green, and blue LEDs was connected to pins 5, 6, and 7 respectively. Addressing the conditions in the if-else statements, a condition wherein the new input sequence is not equal to the previous loop's input sequence is added, so it will only update the states of each output when the input sequence is changed. Following the truth table, when the new input sequence is 0, pins 5 to 7 was put in a low state. When the new input sequence is 1, the states of pin 5 to 7 is low, low, high respectively. The buzzer makes a 1000 Hz tone since there is only one LED working, and also its value is 1 as shown in the truth table. When the new input sequence is 3, the states of pin 5 to 7 is low, high, low respectively. The buzzer was also made to make a sound in this sequence. When the new input sequence is 3, the states of pin 5 to 7 is low, high, high respectively. Since there are 2 LEDs working, the buzzer was made not to sound in this sequence. The truth table also shows the value of the buzzer is 0 at this input sequence. When the new input sequence is 4, the states of pin 5 to 7 is high, low, low respectively. The buzzer also makes a 1 kHz tone in this sequence since only one of the LEDs is working. When the new input sequence is 5, the states of pin 5 to 7 is low, high, low respectively. The buzzer was made not to sound in this sequence. When the new input sequence is 6, the states of pin 5 to 7 is high, high, low respectively. The buzzer was made not to sound in this sequence. Lastly, when the new input sequence is 5, the states of pin 5 to 7 is all high, meaning all LEDs is working, and so the buzzer was made not to sound in this sequence. This next part is where the LEDs, which have a value of 1 in the truth table, will blink and not just stay lit for the whole time. The same goes with the buzzer. It was made to produce a beeping sound and not just a continuous 1 kHz tone. If the new input sequence is the same as the old input sequence, all the output pins were put in low state and the buzzer is made not to sound. This way, as an example, when you press input 1, the input sequence will be 4 and the red LED will be lit. If in the next loop input 1 is still pressed, then the input sequence will be the same as the previous one and the red LED will be switched off. The new underscore variable was assigned 0, so if input 1 is still pressed on the next loop, the old input sequence will be 0, and the if-else statements, as explained, would light up the red LED again. At the end of the loop function, the new input sequence is assigned as the old input sequence as reference for the next loop. The angle of the servo is also updated. The 0 to 180 degree range was divided into 8 equally spaced angles. The formula makes it so that as the input sequence increases from 0 to 7, the angle goes nearer the reference positive x-axis. When the input sequence is 0 wherein no input is pressed, the angle is 180 degrees, pointing directly left. When the input sequence is 7 wherein all input is pressed, the angle is 0 degrees, pointing directly right. There is a delay of 1000 milliseconds or 1 second, so upon blinking of the LEDs and beeping of the buzzer, they will stay on for 1 second and off for 1 second in each cycle.
Sequence 1. Sequence 2. Sequence 3. Sequence 4. Sequence 5. Sequence 6. Sequence 7. Here is an actual picture of my project. We have the Arduino Uno board, the 3 push buttons, the 3 LEDs, the buzzer, and the servo. Sequence 1. Sequence 2. Sequence 3. Sequence 4. Sequence 5. Sequence 6. Sequence 7.
Here is my Arduino Uno project. And that ends my video presentation. Thank you for listening.